Hi, my name is Ingrid Carlson, and I'm presenting the study called The Effect of Muscle Activation on Muscle Fatigue Over Time Using EMG. In the textbook by Newman, he explained that electromyography, or EMG, is an effective tool for measuring muscle activation. He also stated that EMG data can be distorted by things like movement of the electrodes and cables, biofeedback from other muscles, or electromagnetic radiation of other sources. In a study by Souza et al., they found that the wrist extensor's motor unit activity decreased as muscles fatigued. And a study by Beck et al. That looked at the conduction velocity of the biceps brachii had similar findings. The current study shows only some signs of muscle fatigue over time. However, there may be inaccuracies in the data collection that skewed the results. Ultimately, it's important to understand how muscle fatigue works because it can give important insight for physical therapy treatment. The purpose of this study was to look at muscle motor unit activation of both flexors and extensors of the wrist during isometric contraction over a period of time. I hypothesized that the activation of motor units of both flexors and extensors of the wrist would increase initially and then decrease with fatigue. All 8 subjects were healthy individuals who volunteered from the DPT class of 2021. Next to begin the study, each student's dominant arm was prepared for EMG measurement by shaving and cleaning the arm and wrist area. Then electrode pads were placed on the extensors and flexors of the wrist and on the biceps brachii for grounding. Next, the hand grip dynamometer was adjusted to fit each subject. Before the grip test, peak grip force was tested for each subject. This reading was designated to be the maximum voluntary contraction force, or MVC. We then calculated 25% of the MVC for each subject's peak force. Each subject had to maintain this force throughout the test until they reached fatigue. Subjects were coached by researchers to maintain as close to 25% of the MVC as possible. Throughout the grip test, EMG data was collected and recorded every 15 seconds until the subjects fatigued. In the analysis, the standard deviation and mean of the flexor and extensor EMG data was calculated for each 15-second interval data point. I found that muscle activity initially increased and then decreased as time went on and muscles fatigued. Subject 4 was the first to fatigue at 195 seconds. And subjects 1 and 5 fatigued last at 450 seconds. In conclusion, the data supports the hypothesis that activation will increase during the beginning of the test and decrease due to fatigue. As Newman explained, the initial increase in muscle activation is due to increased muscle recruitment, and as the muscle works to maintain its force, the motor unit activity eventually decreases and ultimately leads to fatigue. It should be noted that the data only shows some activation decrease as each subject fatigued and stopped the test. However, there is still a general decrease in muscle activation, which supports the literature that says that muscle activation will decrease with fatigue. The variability of our EMG data may be due to biofeedback from other muscles or interferences from other electrical signals. This study is clinically relevant to physical therapy because if a patient has an injury or morbidity, measuring EMG can provide important insight about which muscles are not functioning at their full capacity. When motor units are slow to fire, the muscles cannot produce enough force to support a movement. These muscles may then fatigue more quickly, and this could lead to injury for the patient. Knowing this about a patient can help a physical therapist prescribe safe and effective exercise. Thank you for listening, and I hope you enjoyed.